Hello guys, welcome back to my YouTube channel, and in today's video we are going to discuss about rationalizing the denominator. So when you are rationalizing the denominator, for example, you are given square root a all over square root b, assuming maybe plus square root c. So this is our denominator. When we are rationalizing, we apply a concept known as on the denominator only. On the denominator. Here is the denominator. This one. This is the denominator. This is our numerator denominator. So on the denominator, we apply a concept called difference. Difference of two squares. Difference of two squares. What do I mean? In difference of two squares, always we say x squared, let's say minus 1, is equals to x plus 1 and the x minus 1, or maybe 4x squared minus 1 is equals to bracket 2x plus 1 or 2x minus 1. So these are difference of two squares or different two brackets, right? So if you are rationalizing denominator, for example, like I said, we have a root 2a over square root of b plus square root of c. It means here you are multiplying with a root of b minus root 2c all over a root of b minus root 2c. So the denominator here, you can see it is a difference of two squares, but we multiply it both sides on top and at the bottom. By doing so, square root of a times a square root of b, we get a square root of a b. Okay, same goes square root of a times a minus square root of c, we get minus square root of a c all over. Now, since here we're saying it's a difference of two squares, what you just do a bracket here, then square root b bracket, then you put a square minus the bracket square root c, then a square. So this is the concept now. Here when you say difference of two square, we're just talking about these two brackets. So by the end of the day, you have a square root of a b, very sorry about my handwriting, minus square root of a c all over, obviously, a square root of b power 2. If you are to remember exponent, we are saying a square root of b is equals to b power a half. So now if we are to put a bracket and 2 here, it means we are putting a bracket and a 2 outside, and this is the multiple exponent. And with multiple exponent, we can cancel here, so you remain with only a, b right here. So same goes, it goes here, same goes here, we remain with a b minus a c. The main concept about rationalizing the denominator is to make sure that the denominator is not having a root. Let us take a look into an example, a simple one, a basic example. Square root 5, let us say square root 5 all over square root 5. In this case, you just multiply by a square root of 5 both sides, and 5 square root of 5 times square root of 5, we get 5, because we are just saying square root of 5 here times 5 inside is equals to square root of 20, 5 inside, which gives us nothing but 5. Same goes here, square root of 5 times square root of 5, we get 5. So our final answer is 1. Now, let us take a look into a different scenario with numbers. You're having square root of 3 plus square root of 5 all over square root of 3 minus square root of 5. In our previous case, we were checking with a plus here. Remember, as long as the denominator is having a root, like I said, we apply difference of two squares. So let us do square root of 3 plus, meaning the sign will change, equals to square root 5 all over square root 3 plus square root 5. Here, we rationalize denominator only. So in this case now, we are going to multiply what is on top. For the student that I teach, I normally call this 1 and this is 2. So that they see what's going on. So I say we start with 1 here. So with the 1, it's root 3, then bracket, then I take all this, which is root 3 plus root 5. Then I told my kid that we take the plus sign, the plus root, which is the second one, which is a positive. So root 5. This is 2. Then bracket again. Then we take all of it. So I do that so that my kids won't get confused on expansion of radicals. So this is what I told them. Then it goes like this now. Then below here, it is difference of two squares, like what we have discussed. So it is 3 and the power 2 minus always bracket square root 5 power 2. So now it's only about to expand this. Square root 3 times the square root 3. We agree when we say square root 5 times square root 5 is 5. So square root 3 times square root 3, we get 3. Plus square root 3 times a square root 5, it means we get a square root 15. Because when we say square root 2 times square root 3, we said we get a square root 6. So here, square root 3 times square root 5, we get a square root of 15. And also, plus, now we are on 2 here. Square root 5 times this number, we get a square root 15. Plus, square root 5 times square root 5, just like that, we get 5, okay? Then our difference of two squares will have nothing but 3 minus 5. So we can actually see that our final solution is 3 plus 5, we get 8. Root 15 plus root 15, it's like let root 15 be x, right? So it will be x plus x is equals to 2x. If we let x equals to root 15, right? So here it means we are having a plus 2 root 15. So we have 2 root 15, right? 2 root 15. Just like x plus x, if we are to let x be root 15. All over minus 2. So now, we need to divide to simplify here, okay? We need to simplify. So this number and this number, we get for negative, of course. Here again, we get again negative 1, isn't it? Which give us nothing but minus 4 minus root 15. And we can filter out a negative. Then we say bracket 4 plus root 15. That will be that. And why do we divide here and here? It is simple. Because it is a single number. It will come as 8 over minus 2 plus 2 root 15 over minus 2. So to go here, we just make a LCM, or the LCM of this number is minus 2. So here it goes 8 and it goes to root 15. So here you better cancel here and here. Whenever the numbers cannot be cancelled, for example, here there is 9. If there is 9 here, you cannot divide. It means your mathematics will end right here. Anyway, let us take a look into another example. Example, we're having 2 all over 3 minus root 5. So to rationalize the denominator, we do the same. We put a plus on this side, root 5 all over 3 plus root 5. So when you are rationalizing the denominator here now we are multiplying only this with all that. And we get nothing but 6 plus 2 root 5 all over bracket 3 square minus bracket a square root of 5 square. That's what we have been doing. So now, if that is the case, we get our answer as 6 plus 2 root 5 all over 3 root 2, we get 9. Here we get nothing but 5. And our final solution is 6 plus 2 root 5 all over 4. Then we can simplify these two, okay, by dividing both by 2. Then 3 here, 1, which gives us nothing but 3 plus root 5 all over 2. So after rationalizing the denominator, this will be our final answer. So you can actually see that the concept of rationalizing the denominator is to understand here, which is the difference of 2 square, and how to expand the radicals. That's the key, to know how to expand radicals. And there are some cases in radicals where you are getting some numbers. For example, you are asked to simplify a number. Let us say find the square root of 12. So if you don't know how to find the square root of 12 or to simplify this, I normally teach my kids to do prime factorization. 12, we start with a 2 here, we get 6, 2 here, 3, then 3, 1. So it means you are getting 2 power 2 times 3, which is nothing but 4 times 3, right? So if that is the case, it means on inside the square root, we are having 4 times 3. If you are to split these two, you are having square root of 4 times the square root of 3, which gives you an answer of 2 square root of 3. So we are saying the square root of 12 is nothing but 2 root 3 if you are to simplify. To simplify the square root of 12, you get this. Same goes if you are to be asked probably to find the square root, assuming 32. So for 32, you just look for, you can do prime factorization, or you can find two numbers that you can multiply. For example, 16 and 2. And we have the square root of 16 here, which is 4. And the square root of 2, we don't have. So you may find out the square root of 32 is 4 root 2. So this concept will help you if you are asked to simplify radicals. If the number is too big, you use the prime factorization. If you use prime factorization, you find numbers that are suitable for your solution. Anyways, here is your exercise. Okay, here is your exercise. I want you to rationalize the denominator of square root 2 all over square root 10 minus square root 8. Okay, this is all, guys. Thank you guys for watching. See you on my next video. Bye bye.